So in this video, we're doing function notation as just kind of a broad introduction to functions, domain and range, and whether something is a function, yes or no. So first, some key points. Domain is all the x values. So domain goes with x. If you're given a graph and it says to find the domain, you're going to go the left furthest point to the right furthest point. It gets brackets if it's a number for our purposes. If you're doing infinity, you're going to use parentheses. So domain is your x values, left furthest to the right furthest. Range is your set of all y values, so range goes with y. With your graphs, because it's the y values, you're going to go the bottom to the top, get brackets if it's numbers. If it's infinity or negative infinity, you get parentheses. So let's do some examples. So find the domain. Notice they gave me an equation. They didn't give me a graph, so I don't do the left to right, bottom to top, all that stuff. They gave me an equation. So think about this equation. This is a line, and I should know that because coming out of chapter 4, it has a y-intercept of 9, y-intercept of 9, and then a slope of negative 6 over 1. So I'm going to go down 6 and over 1. Now, I've got a graph. The domain of that thing, I can do, what are the x values that can be? Well, farthest to the left is negative infinity. Farthest to the right is positive infinity. So with lines, there are no restrictions. I can be any number. Any number I can plug in for x and get out a y. So they call this all real numbers. Always for your line, the equation is going to be all real numbers. Now notice the example on the right. This is not a line. I've got x's on the top and bottom. This is called a rational expression, and you'll do this in Math 102. But for now, looking at domain and range, think back to this thing, the no and okay. If you remember, no, that was undefined because the denominator cannot be 0. So if you're given a crazy fraction like this, you're going to take the denominator and set it equal to 0 because that's going to be the problem area because you can't have a denominator of 0. So I'm going to solve this thing, which means my domain is going to be everything's good except 1/4. And the way you'll put it into Hawks is negative infinity to 1/4, bracket, parenthesis, and then I'm good again from 1/4 to positive infinity. And again, that is just when you have a denominator. All right, so my next example is, okay, we'll determine if the graph is a function. So if the graph is a function, it's going to pass what's called the vertical line test. The vertical line test says that there is no point on the graph where you can draw a vertical line and connect them up. So the way I do it is I use your pencil, use your finger, use something that's vertical, and take it and drag it across the screen so that you're essentially pulling a vertical line across this. Is there any place where a vertical line would make 2 points touch? No. So that thing is a function. If it passes the vertical line test, it is a function. Okay, so identify the domain and range. We said domain was left to right. So the domain, the furthest point to the left that this graph goes is on and on and on and on and on and on and on for a negative infinity. The furthest to the right that it goes is on and on and on and on to infinity. So my domain is going to be negative infinity to infinity, and in Hawks, they're going to write that as all real numbers. Now the range, remember, is bottom to top. So bottom, well, the furthest point down this graph goes is 0. to top, the furthest up this graph goes is forever. So my range will actually be 0 to positive infinity. All right, so now again, determine if the graph is a function. Now if you look at this graph, it's a circle. If I draw a vertical line right there, I am intersecting the graph at 2 points. That means it has failed the vertical line test, which means it is not a function. And again, if the vertical line test says, is there any place on the graph where you can draw a vertical line and connect 2 or more points? If it fails the vertical line test, it's not a function. If it doesn't fail the vertical line test, if it passes, it is a function. All right, so then the next step is going to say find the domain and range. Again, I'm going domain left to right. So if I'm on this graph, the furthest point to the left is right here at x equals 0. The furthest point to the right is 7. So my graph is going to go from 0 to 7. The furthest point down my graph goes is right here, which would be -4. The furthest point up it goes would be here, which is +4. So my graph actually goes from bottom, -4, to top, +4. So that's my domain and range. All right, next example says, okay, here's function notation. And we saw on the first slide that function notation is read as f of x. This is just another name for y. So this is just calling an equation, instead of calling it y, calling it f. So function notation says, take this number and plug it in place of x. So f of -3 means in the equation f, this one right here, replace x with a -3. So I have -3 and -3. I'm replacing it with an x, so 4 times x cubed, 4 times -3 cubed, plus 2 times -3. So I'm going to evaluate this. Well, my order of operations says evaluate exponents first. -3 times -3 times -3 will give you 27. Carry everything down. Now do your multiplication. 27 times 4 gives you 108. And then 2 times -3 gives you -6. 108 minus 6 gives you 102. So that is your answer. Now the next one says evaluate f of b. So we said whatever's in those parentheses says plug in x equals b. Okay, so where there was an x, I'm going to replace it with a b. Now I can't simplify that because I don't have any numbers, so actually that one is where you leave it, 4b cubed plus 2b, because I can't combine up anything. Last example says, given the following relation, determine the domain, range, and is the relation a function. So, domain, remember we said was all the x values. So when you're given a list of points, you're just going to go through and list off all the x values. So my domain is 8, 0, -2, -3, 9, 0. So 8, 0, -2, -3, 9, 0. Now when I put them in the actual domain, I'm going to put them in chronological order. So I want the smallest number first, which would be -3, -2, 0. Notice I have 2 zeros. I don't need to write that twice, so just 1 0 will suffice. So I've got -3, -2, 0, and then 8 and 9. So those are my domain. My range is going to be the same thing, except I'll be listing off my y's. So -6, -3, 0, -7, -3, 2. So I'm going to list them off in least to greatest order. So I have -7, -6, negative 3. Again, I have two negative 3's, but I don't need to list them but once. 0 and 2. Now, if a relation is a function, remember the vertical line test, those are my x's, hoi vux, x. So if a relation is a function, you can't have any repeated x's. So if you have repeated x values, and it is not a function. So we saw up here that I had a 0 and a 0, so that 0 is being repeated, so this thing is not a function. If you don't have any x values being repeated, then it is a function.